Hey guys, in this video I'm going to explain how I have implemented AutoML practices on BERT classified model on AWS. Okay, so this is the roadmap that I have followed. The first one is dataset collection, then we'll be pre-processing the data, then after that the initial model will be trained, then that initial model will be deployed on Sagemaker endpoint, then after that the model inference API will be created, and after that we will implement the AutoML practices. Okay. So the dataset has been collected from this website. It contains about 19,000 documents of 20 news groups with multiple labels such as this. Okay, for the data pre-processing part, let's go to the notebook that I have followed. This is the notebook that I followed, and here we are loading the data, and then we'll be creating a pandas data frame, empty pandas data frame, and putting the data inside it. Okay, so here the data frame has been created, then we'll be shuffling the data, and after that we'll be applying encoding on this column. Okay, and this data set is as good to train after some data cleaning step here. Okay, so now let's go to the model training notebook. These are the libraries that are required, and yeah, here we are loading the data set. Then the dataset is divided into three parts: the training, test, and validation split. These are the hyperparameters. This is the tokenizer that we will be using, and here the dataset custom dataset class has been created, and here the custom dataset class has been instantiated for the training, validation, and test dataset, and here the data loaders are created. Then this is where we have defined the model class, and here the model has been instantiated. Then here we have defined the loss function, the optimizer. This is the function which trains the model, and this is the function which evaluates the model. So we'll be training the model and evaluating it, and if it performs better than its previous turn, then we'll be saving the state dict or the weights in our local file system. So now that we have got the best model for the number of epochs, we'll be loading the model for evaluation. So on the test data set, we are getting about 98.8% accuracy, which is quite good. Okay, so now let's predict on a raw text. This is just an inference function that I've created. Okay, this is the raw text for which we will be classifying, and the model has classified the labels as this. Alright, so now let's go to our Sagemaker notebook and see what we can do for the next step. And the next step is model deployment on Sagemaker endpoint. So this is a Sagemaker notebook. For the first step is creating an inference script. This script will be used by the Sagemaker endpoint. It has some function that will be required by the Sagemaker endpoint, such as the model fn, which loads the model, input fn, which processes the input, then predict fn, which calculates the prediction, and then after that the output fn, which processes the output. Okay, so now the weights that we have got by training it on the Kaggle notebook, will be saving it to the S3 bucket, and then after that we'll be creating an instance of a PyTorch model and passing the inference script and the location of our newly trained weights to it, and then we'll be deploying this model, this endpoint, on an instance type of ML M5 large. So I have already deployed it, so because it takes a bit of time. So now test if it works or not. So we'll be testing on this input, and yeah, it works. It is classifying the labels of this text as politics and talk, which is quite true. Alright, so for the next step, which is set up a model inference, we will do two things. The first one is creation of a lambda function, and the another one is creation of API gateway, and then attaching the API gateway to the lambda function. Alright, so yeah, this is the lambda function that has been created, and this is the API gateway. So let's look at the code. Okay, so what it does is it gets the data from the user the user sends the data through the API, and it passes it to the endpoint by invoking the endpoint. Then it gets the prediction, sends it back to the API gateway, which sends it back to the user. So which is quite simple. So now let's see if our API works or not. Okay, so yeah, we are going to send this text in the JSON format. Okay, so now let's send it, and yeah, we are getting the labels as politics and talk, which is true. Okay, so now for the next step, which is AutoML implementation. All right, so up until now we have done this part: model endpoint creation, the lambda function creation, the creation of API gateways, the user sending data, and all that. We have already done it, right? So now what we'll do, we will create another lambda function now and attach it to an API gateway. This API gateway will get feedback data from the user, pass it to the lambda function. Now this feedback data will first be pre-processed, then it will update the previously present data set in the S3 bucket, and after that this lambda function will start a new training job which will train our model on the new data set. And after the training job has started, it will give an acknowledgement to the lambda function, and the lambda function will send the response that yes, the function has been successfully executed and the training job is started. Okay, and now this training job is running, right? So after the training job has finished, it will trigger an EventBridge rule that I have created. Now this EventBridge rule will then trigger another lambda function. Now this lambda function will use the weights that we have got by training our model on the new data set to update our pre-existing endpoint. Alright, but keeping the name same, as obviously to maintain continuousness and simplicity. Okay, so this is how we have implemented AutoML in this system. So now let's look at this part, the lambda functions and all that. So yeah, this is the lambda function which will be used to send the new data. Okay, so this function updates the data set by taking the data the user has sent, and this is the part which starts a new training job. All right, and after the training job has started and finished, it will trigger an EventBridge rule. As you can see in the rule section, I have also created an update model rule. Now this rule will be triggered, and then this rule will target this lambda function, BERT update. What this lambda function does is, let's go to the code. This lambda function updates our endpoint by creating another endpoint with the same name but with the new weights. Alright, so now let's see how it works, and even if it works or not. Okay, so yeah, this is the API we have, which is attached to this lambda function BERT2, as you can see. Let's see, and we'll be making a post request, and this is the data we'll be sending in the JSON format. We can also send in CSV format by making minor changes, and let's see, send. Alright, so we have got the confirmation that the lambda function has been executed. So now let's go to our Sagemaker and let's look at the training jobs. So as you can see, a new training job is in progress, right? So it has started a new training job, and let's wait until this training job finishes. It will take a few minutes. Alright, so I'll pause the video up until then. Alright, so now that the training job has finished, let's look at our endpoints. And as you can see, a new endpoint is getting created with the same name, obviously. So also let's wait for a few minutes for it to be created. So yeah. Alright, so as you can see, the endpoint is active. Okay, so Yeah, now let's take a step back and remember how this works. So first of all, now yeah, we'll be calling an API call. We'll be making an API call which is attached to a lambda function. BERT2, what it does is it updates our data set which with the new data, and then after that it starts a new training job. And after the training job has completed, it is going to trigger a rule. As you can see, a new rule has been the rule has been triggered here before some time. Okay, so yeah, so a new rule is getting triggered. Now this trigger will then target a lambda function, BERT update. Now, and this lambda function will then update our endpoint with the new weights. So now let's see if our previous API inference API still works with this new model which we have trained or not. Now remember that I have trained this model on a dummy data set, as the actual training process is really long. So the obviously the classification levels will not be correct, but still we will get some outputs. Okay, so let's see. Yeah, as you can see, we have got the outputs. So yeah, for the next step we'll look at some future scope and improvement that we can do to the system. The first one is hyperparameter tuning. I have not implemented this because it takes large compute. Okay, and then we can also use a secondary endpoint to ensure close to 100% of uptime. And then we can also set an event to train the model when the traffic to the endpoint is really low, or there is no traffic at all. Okay, so thank you for your time, and yeah,